Here we've got a reacting mass percentage yield calculation. We've got a question there that says sodium azide is made by reacting dinitrogen monoxide gas with sodium amide. Gives the equation, and it says calculate the mass of sodium amide, which is this, the mass of this that's needed to produce 550 grams, assuming there's a 95% yield for the reaction. So the equation looks quite complicated. It's one that we don't really ever study. But the only substances that are of any real importance in this question is the two sodium compounds, sodium amide and sodium azide. What it's saying is that we're saying that we're going to produce 550 grams and it's a 95% yield. And we're being asked, right, what mass of this am I going to need to react in order to produce this amount of sodium azide, given that it's a 95% yield? The first thing we've got to do is we've got to work out then what the mass of this sodium azide you would get if the yield was 100%. So you'd say if yield was 100%, the mass of NaNA3 would be, you would do 550 times 100 over 95. That would give you 578 grams, and that's the first thing that we need to do. So working out the mass of sodium azide you'd obtain if the yield was 100%. So now we've done that, we can work out the mass of this eventually that you would need to produce this. Before we do that, we've got to work out the moles of this sodium azide. Because once we work out the moles of this, we can work out the moles of this, then we can work out this mass. So that's where we're going with this one. So moles, remember, moles is mass divided by MR. So the mass is 578. And the MR of this sodium azide is 65. And that's going to give you 8.91 moles. So, next thing we need to do then is we've worked out the number of moles of this, okay, which would give 100% yield. Now you've got to work out the number of moles of sodium amide. And you can see that for every mole of this NaNA3, which is formed, you need 2 moles of NaNH2. So number 3 then, to work out moles of NaNH2. So you would say then we've got 8.91 and we need to multiply that by 2 to give us 17.82 moles. So remember that the moles of this sodium amide, the moles of this here has to be bigger than the moles of this here. In fact, it's always going to be 2 times bigger because in the equation you've got a mole ratio of 2 to 1. So this is going to be 2 times bigger than this. Step 4, we now need to work out the mass, and this is the mass, then this will give us the final answer, the mass of NaNH2. And again, mass is Mr. Moles. So we've got an MR of 39. Multiply that by the number of moles, which is 17.82. That will give you a mass of 695 grams. And that is your final answer. So it is quite a tricky one, that. But hopefully by doing more questions of this type, you'll get to see the patterns that arise.